Hi guys, welcome to Manipur Free Tutorials. Today we are going to discuss on how to build an AI model from scratch. So first, to build a model from the scratch that can be trained on PDF data means you can build the source of the data should be in the PDF format. It can be a PDF book, it can be a story writing, or it can be any translation. Whatever data you have on PDF data, that data I'm going to use it as a source for training. Now, the first step is like to build a model. Here, we are going to use feed forward neural network that is already written in TensorFlow, and you can go through there. And we are going to use PDF data where it will be trained and then stored as a model. Now, what are the tools requires? So please make sure that these are the tools available in your computers like Visual Studio, Python 3.8, or maybe Python 3.10, Node.js, and Python libraries are like these are the libraries you need to install, like say PyMuPDF, Flask, NumPy, TensorFlow, NLTK. This is for language translation, and then Skykit Learn. These are for presentation. So you need to have all these tools in your computer. Please make sure that these tools requires mandatory to develop these particular applications. Okay, so we are going to start the activity. First, what we are going to do, we are going to process the data. So here we are using a PyMuDF PDF, which is also sometimes called as fitch. These are the algorithm which is used to extract the data from the PDF. First we will read the data from the PDF, and then we store those extracted data in a structure format. Maybe you want to put them into sentence by sentence, correct? So in PDF there are a lot of sentence, lot of lines, lot of paragraphs will be there. So we want to structure into sentence first. So this is one algorithm first we want to do in the initial process of the data. Second is tokenization and vectorization. Here, I am not going deeper into the information about what is tokenization and vectorization, but please have in your mind that tokenization means breaking down of all those sentences into simple words. It can be smallest part of that particular sentence. In a sentence, there can be vowels like A, E, I, O, U. We want to break down into that, and then it can be it can be the smallest one, a, right? And even comma, full stops, these are all considered as tokens. So token is the unit of tokenization. So when you do a tokenization process, you get the smallest part of a particular sentence is called token. So we split them into words, or maybe it can be phrases, which you know that. Okay, so convert the text that into a numerical formats, what we call as a word embeddings. So word embeddings means what? Converting your sentences, or maybe your token, that maybe the smallest token, I want to present them by giving a numerical number. Number can be anything from 0 to n. N means any number. So how many tokens will be there in that particular PDF data? That speaks the way how you're going to train. So I'm going to break down all those words into token using word embeddings format. Okay, so there are algorithms, many algorithms are available to convert the word embedding. There may be word to back, there may be fast text or simple back of words approach. There are many others algorithms are available. You have to convert, you are giving a number to each and every token you get it from that particular sentence. Now next, the third one is the most important one, which is training. Now here we call as a model train. It is a build. Right now in this example I'm going to use a simple neural network. Okay, and that will be a NumPy and TensorFlow relationship, which is already written down into codes in the Python. So in Python you will have a NumPy, TensorFlow, already it is there. So that is the mathematic calculations which has already been converted into codings using Python. Now the query processing here, it is something like this. So every data you are going to query, that means it is a user input. You are going to ask it as a prompt. So when you are entering a prompt, it's okay, that prompt will be also undergo the same process of giving a numeric points to each and every tokens you get. You have to go through the tokenization process, then you will get a token, and from the token you are going to get a numerical format. Then we will compute a similarity between the query and the stored procedure. It's something like we have already trained a data that is already in the inside your model, and when I want to query my input, then what we do, we have to run a similarity. There are a lot of algorithms available for similarity. They give me cosine similarity. There are a lot of similarities uh, algorithms are available. Okay, and then you can compare those data and send out the best possible output from your model. Now then we retrieve those data, and then we give you as a relevant response, and you want to display it for the users, or you want to store it as a response. That is up to you. So now, what is the step by step implementations we are going to implement now? First, we need to install the dependencies. Like I have already told you that the PyMuPDF, Flask, NumPy, and TensorFlow, NLTK, and scikit-learn, these are the dependency required for this particular applications. So you need to install this using pip, and then we want to go for data processing. So when you go for data processing, I already have the codes for data processing, which I have already written down and kept it, so that I can go very fast to show you how the output will work out. And then we have a tokenization and vectorization. So here we are going to implement using BOW, that is a back of word. So we are going to use this algorithm called back of word, and then this model to convert the text into numerical format. That is code also available. Now model training, here we are going to use a feed forward neural network in the TensorFlow. So from the TensorFlow we use this feed forward neural network, and this will be using for training the data what you have collected. Then we build up one backend API. So these APIs are used for interface between the HTML code and the Python code. So I mean, you can send a query from the HTML, and then it will go and transfer the information to Python code. The Python code will run against the model, and that model will return you a response. That response will be displayed again to the HTML. Now the front end will be like, you will be having a HTML and JavaScript that will be designed as a GUI to interface the users and then display the response. This also, all the codes are available. So I will go through this code one by one, and then I will build up an application here in this video, and then finally we'll run the codes, and then we'll check how the output works. Okay guys? Okay, without further delay, let's go to the codes. Okay, so now in order to start our application, first we need to open a Visual Studio Code. So first I will open my Visual Studio 2022. So here we can set up a basic HTML and JavaScript layout, so that I don't want to do those scratch work and show you how to do the work. So maybe it is already available, so we can go for new projects. So when you go for the new projects, uh, okay, in the new project, you just you select this Flask web project, because we are going to use the Flask API to make this web project. And then you just name here as a simple uh, model. Okay, simple model. I'm just naming as a simple model. I will store into a location where I can recover it in the future. So I have some folders where I used to store here. So I'll just selecting the folder where I usually store my projects, so you can store in your own locations. And then let's create the model. Okay, let's create the project, I'm sorry. So let's create the project now. I am going to get a what to say, a code base where I want to use it as an interface for users and the backend code. Okay, so first it is open. I will put up this code into the Git repository, so you may future you can use to this git repository and call this code, and you can make use of it. So we already have a few uh, model already been done. So we'll go to the simpler explorer. So you see here all the required code base is available. So here I'm going to create uh, my files which are required to use it. So you can add your own files using this, and then you can run from the run server also. So when you do the run server, probably you are going to launch it into this port. So let's see that whether the code base is working okay, or for is there any problem in the code base. First we'll see this code base. Okay, the code base is launching. Okay, now we have a code base. Now this is a code base. I don't want to see all this output, so I will delete it in my code base. So what I can do is I'll go to the folder. It will be in template folder. There is an index format. So these are the display what was going on here. So if you want to keep it, you can keep it. If you don't want, you can just delete it. So as of now I'm going to delete it because I don't want that output. So instead of this I will put my own codes. So here, so what is the code? I already have a few codes, like say for HTML code. This is the HTML code. I have already put it there. So in this HTML code I'm going to put only this portion which is required. So now I'll just put it there along with the script to uh, continue here. Then I just put my code here. Okay, so is this how it will display? We can go and test it. So before that, this is the function which is going to call when you click that particular this one asked button. And so there is a text box which where you can enter your questions, and then you can just ask the you can click the ask button, and then when you click the ask button, this is the code is going to say. So if I say that if this text is which is collected is in the questions, so if the question is empty, I will just want to pop up. So make sure that this code works. So what I will do is if not these questions, so if this question is not uh, if empty, then what I will do is I will put one alert message. So that alert message I'll say questions is empty. So this is what I'm going to display. Whether it will work or not, let's see that. First let's see whether our front end is okay or not. Then we'll go to the backend part. Okay, as usual we see that ask a question, and then I have here I did not write anything, and I will just put the asked. So now question is empty. That means my script is working. So the see where how it is questioning. It is questioning using a JSON file, and then it is waiting for the response. After that it will display into a response. Below it it will display the data called response.data, and this is how I'm going to return the data. So let's see in the view. So what is this view? View is a Python code which will be interfacing that data which is coming from the uh, which you are going to get it from the HTML, and then I'm going to use it in as a backend. So here I am going to write the backend, start with the backend code. So in my folders I already have called Flask API already on some codes are already available. So let me copy this, and then I'll show you. So let me copy this code. So I have put the required. So I don't need this right now because my app is already been done. So here you just see underline because I don't have this that code right now, and I don't have this simple NNN code. So vectorization code and simple NNN code, this is are the two codes I'm going to add it. So for that you can you can create a Python file. So here I will just here as Okay, uh, model simple model. I'll just put a simple model. So simple simple, simple model dot py is a Python file which I'm going to add it here, and in its Python file I'm going to put it my Python code. So what are the Python codes I have? So I have tokenization and I have model training. So these are the two datas I need to bring in into that code. So first I'll copy the first I'll copy this tokenization code, and then let me go here and I'll just paste it my tokenization code. Then I have another class which is I have another class here. This is a model training class, and this model training class also I'll copy it and put it here. So this is these are the two different classes of vector, text vector and then simple this one. So now I'll save it this. So as we planned, we can install the required library using the pip and install all these things. So I have already have some of the library already, so it will not be installing. So requirement already available means it is already installing. So it's right now installing only PyMuDF, that is PDF only it is installed. So the others are already there. So I don't need it. Okay, so let's continue with the coding. Now this is a PDF data which I want to train it, but actually what happened is this PDF data is almost 504, and if I do this sample work, probably I will not be able to complete the training process. It may take longer time and it will be uh, not good for everyone. So what I do is I will extract a few data. So something like what is deep learning. So this data alone, let me extract a few pages. Okay, so how much? Maybe around some 10 pages, something like that. I will put it this data into another word format so that I will be able to do it for testing purpose only. So let me create a word format first. Okay, uh, say sample, and okay, I'm just extracting a few things from there so that I want to show you that how it can be trained. That's all only. So now I will save this as a uh, okay, I mean as a PDF. Let me save it this as a PDF format. Okay, so fine. So now I think it is saving as a PDF format. Okay, great. So now I have a PDF format of the data. So where is my data is saved? It is a sample PDF data which I want to use this sample PDF data for training purpose. So let's go to our project folder where I kept my project, that is simple model. So inside this I'm storing inside a data folder. So in my project I have a folder called data. Inside the data I have a file name called sample. So as we have already seen that we have an HTML file where we have this button called as a train model button, and there is a for query button, that is for prompt button, and these are the script which are interfacing with the Python code which is there in the view. So what are the for training, there is a tag has been used called train, and there is a asked is used for answering the question. So now in the view I already mark the breakpoint so that we can see that it is responding is coming or not. So each and every line will debug, and I'll show you that how it runs. Okay, let's run the code, and seeing is training in progress. So when you saw no that training in progress is message is displayed. So this message is displayed from our script. So here we have seen a training in progress. So now a train tag has been raised, and there is a part is supplied PDF part, but actually this PDF part will be wrong for me right now. What happened is I have to use this part. So no problem. I when I say this, it will be this part will be going to this part and say here. So this is a debug point here. So let me go step by step. And what is the part is been now here? It is reading as uh, sample data PDF, but sample data PDF is not available in the folder. So what I can do is, for time being, I'll uh, because I have not changed the part correctly. So what I'll do, I'll put it into this part where it will access this sample data PDF. Now let's see that sample data.pdf. Now it will process. Now this is a process class where we already have the process class here, this PDF processor. So let me go inside this process and then we'll see that. So now in the self, it is going to give you the path, and then it will do the extract the data. So let's see how fast it extract. Yeah, it's extracted data. Now see here, you can see the whole text is extracted, correct? So with how much is extracted, how it's extracted, let's see that. Okay, I'll copy this, and then what I will do is I will show it out in it here. See here, it is totally a chunk of data is been extracted, but here I need to format it using those line sentences format. Otherwise this I cannot use it for training, correct? So we need to do that. So let's come to the code. So what you will do is you will go for training data. So training data is one more class. Here we have this class, and inside this class it will go for training the model. So here I'll go inside this, and then what is the training it will do here? It will split those data into sentences, then it will go for vectorizer, and then it will return back with a vector. So what is the vector I'm getting here? See, now you will get it as a vector. This time each and every data will have its own vector. Now these are the vector. This is a section of data, what is deep learning, and then these are the vector. And vectorizer is used as TF-IDF vectorizer, that is an TensorFlow vectorizer. And then you go for a training the model, and the text whatever it is there, it is stored into the train data. And then I want to save the model now. So let's save the model. Now this model uh, here it will return as a training completed, and the model is saved now. So what happens is, when I ask the questions, it will raise the questions to the model. So the model will be saved in the folder called train folder. We'll see that. See, these are the model available. So model.pk is another model. These are the text format, and these are the vectorizer format. So now these are the model and text and vectorizer. This is your trained model. So if we use it using a TensorFlow Keras. So now you can see here training. So how it has been training here? The training has been used with the vectorizer, and then it return each and every vector, and then you can extract it is saved here. And then what will happen when we do the extracting? So now let's see here. Let's go to our question. We asked what is uh, Python, or what is I'll say deep learning. I'll just ask the question, what is deep learning, and it has to return the answer. Now let's see that if this part exists, it will nothing will happen. Now the text vector is loaded, vectorizer is loaded, text section is loaded. Now we read the data, the query is been written. So what is a query? So what is the deep learning? This is a query, I got it from my uh, uh, HTML. And then we go for vectorizer, then we go for cosine similarities, and then we go for the best index. And now what is my best index? Best index is what, see here, you are getting everything in numerical. Okay, so these are the numeric which you want to uh, go back and give the response of based on that numeric. So it will give return a response now, and this is a response now. So what is the response it will display here? Let's see that. what is response. See here, what is deep learning response? This chapter covers a high level definition of fundamental concept, timeline of development. All these things are coming here. This is the information which I fed it inside the training. So this is the data it is coming here. So how accurate and all that, you can still find out the accuracy of your model. Maybe you have to train more data, probably you may get a better answer. Okay, so in the here what we understood now, the implementation process, like we first extract the data using PyMuDF algorithm, and then we split the sentences into a vectorizer using TF-IDF. Then we compute a cosine similarities to find the best matching answer. Then we provide a Flask API to serve the answer to the HTML, and the HTML and JavaScripts are using to send the queries and display the response. Okay, with this we are ending up for this course. Next in upcoming course, we are going to start on the more on deep learning. So how I can use this data in deep learning, and we will see deep learning using model like OpenAI, or maybe we can use GPT 4. We can use this kind of algorithm. We will use this kind of existing model. Okay, and then we will train the model with our data, and then we will see that how the output can be generated using this model. So let's please be tuned for the next video. Thank you guys, have a nice time. Bye bye.